Hi, this video is just going to quickly recap average rate of change and show you how to use it for exponential functions. So just remember, every time you see average rate of change, you are going to be doing y2 minus y1 over x2 minus x1. And when they give you an interval, they're giving you x1 and x2. So usually in average rate of change problems, they give you the x values and the goal is to find the y values. That way you could do y2 minus y1, x2 minus x1. So in the first example, and this we've done, we have determined the average rate of change from 2 to 4 hours. These are x values. We have x1 and we have x2. And we're going to try to put it into y2 minus y1 over x2 minus x1. Now, we're going to actually go to this graph, and all we know is that x is 2, x1 is 2, and x2 is 4. So can't really get values from this like by just looking at it. You have to actually read the graph, and you have to go to the 2 coordinates. Your first coordinate is 2, 20, and your second coordinate is 4, 60. Now you have your 2x values, but now you have your 2 y values as well. So my y2 was 60, my y1 was 20, x2 is 4, x1 is 2. And then I know you guys, a lot of you like to simplify this in the calculator. Sorry, I meant to say simplify the numerator, then simplify the denominator. I really encourage that you put it in the calculator all at once, and give me a minute to just pull this up. So we're going to do alpha y equals, to get a fraction, 60 minus 20 in the numerator, and in the denominator 4 minus 2. See how I'm putting it in all at once into the calculator? I'm not doing each computation separately. That is really best. Now it tells us that our average rate of change is 20. Now, it's important to note that this is a rate. It's changing 20 y units, or it's gaining 20 units up for each x unit over, if that makes any sense. But my point is that because it's positive, it means the function is increasing. And you can tell that it's positive because the graph is literally, it's going up, it's increasing. So that's just another way to know that your answer is right. For the next example, we have an exponential equation can be used to predict the temperature of a cup of hot chocolate in degrees Fahrenheit after X minutes. What is the approximate average rate of change of the temperature of the hot chocolate in degrees per minute over the interval 0, 6? So as soon as it says average rate of change, we're doing y2 minus y1 over x2 minus x1. Now, our x values are 0 and 6. Before you actually think about try to get this answer, look at what we're dealing with. The base is less than 1, so this is an exponential decay function. Because the function is decreasing, you're going to have a negative slope, which means you're going to have a negative average rate of change. Your answer cannot be positive because this graph is going down. In order to get the equation in your calculator, you are going to do y equals 90 times 0.86 to the x power plus 69. And we're going to put that in the calculator. 90 times 0.86 plus 69. All right, so let's see. If you also think about it, this equation should have a negative average rate of change because we're talking about a cup of coffee and the temperature of it. A temperature of the cup of coffee is going to decrease, right? Like when you get a hot steaming cup of coffee, it starts to cool down, which means the temperature is decreasing. It makes sense to have a negative average rate of change. Anyway, we are going from 0 to 6. So at 0, oops, we have 159. Which also makes sense because you know how we usually start at 0, 1 for exponentials? Well, we have a vertical stretch of 90, so we have really 0, 90, but we also have a shift up by 69. So it's 90 plus 69 gives us our initial of gives us an initial of 159, and that's how I knew I made a mistake because I accidentally wrote 150, but it's 159. We also need 6, so 6 was 105.41. Gonna double check that I actually copied it right since last time I didn't. 105.41, yeah. So now that you have your x values and your y values, notice how again the table is going down, it's decreasing. We should have a negative answer. We are going to subtract the second values minus the first values. So 105.41 minus 159 over 6 minus 0, or just 6 if you would like. So 105.41 minus 159 over 6 minus 0 gives me negative 8.93. And that is choice 1. So it's literally the same thing we have done before, y2 minus y1 over x2 minus x1. The only difference is that you have an exponential equation.